Thanks, Peter, for the good presentation. I'm actually going to present the use case that goes behind your. So yeah, just gonna quickly introduce myself and my company. I don't know if by show of hands, who knows Schneider Electric? All right. So for those who haven't raised their hand, it's electrical equipment manufacturer. And on top of electrical equipment, we have as well industrial automation equipment, and we do as well the software that goes along with it, and the service that goes along the software, and the consulting services, which are represent that help deliver all the portfolio. We are a 30 billion euro company, 130,000 people, 200 manufacturing sites, 90 distribution centers across the world. Decent sized company. Today I'm going to talk about electronic batch record that support audit and how we implemented a solution, what was the issue on site, so an auditor coming and saying not good enough, the solution which was put in place. You might find that it's not exactly as well as top tech of a use case. So bear with me, because the end of the presentation explain how this is contributing to future-proofing the operation of a facility and extending the use case to what comes next in terms of functional architecture. And that's hopefully going to break new ground for you if the beginning doesn't. Right, so just a bit about myself. I'm François Disch. I live in the UK, right? The accent, I'm never going to get rid of it, so just get used to it, right? Please. I as well, my background is, so I'm sitting in the company, I'm a consultant. I'm a part of a very new part of the company, which is about explaining how we did transform ourselves and try to spread the good word to the external market. Schneider has gone through a massive transformation over the last 20 years. Now we are second to Cisco in terms of optimized supply chain, let's say smoothness, according to Gartner. Right. So I think we did a good job for ourselves. We have WEF, the World Economic Forum, sites, the showcase of what a good smart factory could look like. They are open for visits. We bring customers on a regular basis to them. There is one in Leeds, not so far away from here. We are keen to, in terms of consulting, keen to help end users to get better at it, not necessarily wanting to consult forever, but for as long as you use Schneider products, we're happy. So that's it. So consultant now. I used to be a consultant for a Big Four for 6 years, and before this, I was for 10 years lead engineer on automation systems. So I'm a bit of both worlds. Let's go. A bit of a generic slide about what are the challenges as we see them in the pharma industry. Obviously, I'm going to look at the digital side of things. Data transparency, figuring out how we can make this data available inside the company, outside the company for auditors, across the whole value chain to help everybody work better, work faster. Let's go to digital engineering, figuring out what is it that we want to measure, then find a way to measure it. It's because it's monitoring is the prerequisite for optimizing, and then we'll be able to get better at what we are doing. Process as well as engineering. There are ways to improve both. Then people. I usually end up with this, but I would like to have a segue with quality and compliance here. So empowered workforce. Giving the right information to the right person at the right time is what makes the difference between digital working, and digital just being a gimmick that is going to be shelved after a couple of months. Last month, we organized for, well, I'm not doing only pharma, I'm a lot in the whiskey and spirit industry at the moment. We enabled a site to have shift meetings at every beginning of shift. Everybody gathered, explained what happened on the last shift, what's the objective of the next shift, what were the blockers, what are the machines which are down, is there any objective change in the schedule or whatever. 11% improvement in 3 weeks. Just the method. I'm not talking about Schneider fancy software. I'm talking about just good manufacturing excellence, Toyota 70s, good old methods. 11% throughput improvement. And the secret was, I can give it to you, just don't repeat that I told you. Instead of setting the target for the week at a point which was not achievable, but the staff, they were not so engaged. So the manufacturing excellence guy from the site decided to gather everybody, take the excuse of having Schneider in place to explain what was the manufacturing methodology that we would have on having those short interval management meetings to discuss at the beginning of each shift, asking the staff, all right, what do you think is achievable? Setting the bar after a discussion, a bit of negotiation, of course, to what was achievable. And the staff got it as a, sort of objective, like a personal objective, and they beat the target. The target was slightly higher than the usual set target of the week. Was much lower than the usual target, but slightly higher than the usual throughput that they had per week. And they beat it because it was fun to do it. But instead of pushing as fast as possible the production through the line and having work in progress accumulating at bottlenecks, smoothing the process allowed them to beat the target. 11% throughput, 0 investment in fancy software or complicated hardware. This is the next step, and we are aiming for as much. So, well, that's my case for empowered workforce. A lot to do with just people. Then quality and compliance. So here we're talking about trying to use the regulatory constraint that we have in the industry to actually help ourselves and do one stone, two birds, tick the box of the auditor, but as well use it as an excuse for investment and doing the right thing for ourselves and helping production, visibility, helping people, helping data transparency to make things work better for our clients and our employees. And this is what we're going to talk about today. So, context of the story, Val Pharma Groups. They told us we can talk about this. It's a success story. Otherwise, I wouldn't talk about it. It's a company which is, well, dates from, it's like 40-year-old, so 45-year-old, so it's good, quite a mature company. It's been through a couple of revolutions already. 3 plants, not huge, 400 people. And the exam questions was, Schneider, can you help us? We'd like to have a system that helps us for well, supervision of our process. And while we are at it, can you help us with the compliance on audits? Because the auditor was not so happy last time they come to visit. And they would like to have some manufacturing execution system functionalities to keep track of quality and process variables. And the sugar coating was about the coaters. It's new machinery that they just acquired, and they wanted to sweat them. Obviously, they was a bit expensive, so they wanted to make sure that they maximize the use of them. All right, here we go. 100% paper management. That's what we started with. We had a recipe delivered to the process leads in paper. Everything was entered manually in the machine. The verification process, it's funny, when you're here and you look at the guy is doing it correctly, when you're turning your back, everything is 100% tick like it was in one go on the piece of paper, strangely enough. And everything is okay, don't worry. So basically it's not done. Manual recording of the main process parameters, so the guy writing down every hour what's the temperature. It's the same for all across the cycle, but still he writes it down. You wonder if it's not written all at the same time at the end of the batch, but hey. And then that's what you record when you know it, but for everything that you don't measure or didn't put it in the procedure, then it's not measured and you don't know. So you don't know what you don't know, for sure. And there's a lot that you know that you don't know that you don't know, if it's clear. Anyway, and then, well, the event log, if you want to get into details, well, it's almost inexistent. So it works. So far, nobody complained. But as we say, well, in a fall, it's not the fall that matters. It's when you land, right? And it hurts. So before you land in a bad position, better try to figure out ways to, fly, wing it a little bit better. This is what it looked like. To me, it looks like a line like 5 here. Does seem that they all wrote this in one go, right? No? Okay. Bon, I'm not looking at names in particular, but this and like a pile of paper like this, you probably don't want to get too much into it, all right? So who was, I've seen this before, still using it? No? Not using it? Okay, bon. Okay, so the story behind it is the Italian Medicine Agency coming after an audit and saying, well, could we have a way to have data which is not manipulable, yeah, transparent, organized? So you've got this ALCOA acronym, and it was not following the data integrity principle. So how do we make this data available? How do we follow good manufacturing practices, right? And it's where it's interesting to start talking about control systems, because the sheer fact of looking at thinking about the process and making it stiff, so, or at least mapped out, is already a big deal, and it already helps. It's an input to configuring the control system, but already doing this exercise surfaces a lot of issues and a lot of good things in the company. Then how do we store production data? How do we digitalize the production process to eliminate the human error? So again, optimizing the process so that the outcome is predictable. So we jumping the gun with the screens here. This is what it looked like in the end. So obviously, I'm not going to promote anything else but Schneider, right? So this is the architecture, all Schneider-based. Drives, which were providing the right speed for the fans. Thesis Island, which is our soft starters for motors. Then you've got the Modicon Pack, which is our industrial automation control system, well, hardware. Aviva coming on top. Aviva is our software company. Before Schneider completely acquired it, it was the biggest industrial software company in the world. For several billions of turnaround in the FTSE 100. It's not in the FTSE 100 anymore. It's part of Schneider. And on to that's edge, so meaning close to the process. And then on top you have cloud-based analytics with historian and recipe manager, and then lifecycle services. Okay, so the whole stack based on Aviva, more or less. I'll get in. Zoom out and look into bigger detail, larger details a little bit later. So this is what we came to. So process parameters management, automated, integrated into the process system. Recipe management following the GMP standards. Data archive in the historian. All the instrumentation logged. Not only the parameters which were asked from the every hour from the operator, which was recorded on paper, but everything in a time series in a retrievable database. Recipe management of existing machines. So since you had some black boxes left and right, you had some common ports. Some information was made available from those machines and then incorporated into the historian database. So you get a richer pool of data to pull from to inform audits, or when a batch didn't work as expected, then you had more than just a bit of paper to revert to, right? And then order execution and reports. So the production wheel. How do we minimize the cleaning in place procedures depending on which kind of products you would have to produce during the week of production, optimizing the number of cycles and so on. And validation service as part of it. So here we have got a special service for pharma that would look at batch records and provide the relationship between quality of the batch and on different parameters. Well, this is a service that we provide on top of the software itself. Right, a couple of screens, larger than before. Who is not impressed? So this is bread and butter. And the case I want to make in this presentation is that we can talk about fancy technologies and AI and machine learning, augmented reality and blockchain, all the rest of it. But if the house is not in order, then you're going to digitalize chaos. And no one can do anything out of chaos. As well, if you talk about the means but not the end, you're not going to get anywhere. If you got an IT guy trying to look at this, it's like, all right, tell me the pipeline and the AWS module that's going to process the data and so on. So, right, what are you trying to do here? Electronic batch records. I want to know what happened, and I want to be able to revert back to it and have a series of KPIs that I want to monitor throughout the length of the batch so that I can provide with confidence that they were not out of range for the duration of the batch. I don't need IT. I need to have clarity on what KPIs they are. And then to come back to, I don't think it's you, Mark, who mentioned McLaren Technologies. The CIO was once saying, I want, for any given problem, I don't need cloud data lake, whatever. I want to know what the exam question is, and then I'll find the thinnest slice of data that answers the exam question. I got Thames Water coming one day, coming to one of our shows, saying, I'm monitoring pumps and stuff and got terabyte of data and it's all stored in Amazon. And but the only people who are making money is actually Amazon, because I don't do anything of the data, but it costs me an eye every time I need to pay the bill for the storage. Thinnest slide of data, right, at McLaren Applied Technologies. They've got enough data from the Formula Ones to, fill data centers. Just take the thinnest slide, that'd be enough. So, and behind this, there is thin slices of data that are animating the mimics and providing the trends. So that's the network architecture. I don't know if it looks like complicated, but basically you have a database that stores data, the network that distributes it, HMI for the people who are working, doing the real work, and the PLC, which is collecting data from the process itself. That's it. And then you've got a nice mimic on the coder that explains where the process is at. And on the bottom, you've got as well the map of the site, which is not too small, as you can see. And you've got parameters on the building management system. So just checking how I'm doing with time. Okay, 15 minutes more. Yeah. Good. So, and that's it. We've got our batch records. So configured as the client wanted them. This is easy to make, very flexible. Everybody has the different ones, but yeah, most of the time it comes like, this is what we have in paper. We'd like to have the same in electronic. And with a bit of maturity, they're like, okay, let's scrap all this. What is it that we wanted in the first place? Okay, let's make a report that looks like convenient for everybody. So that's what they got, and a bit more here. So simple, intuitive, compatible, compliant with CFR 21 CFR Part 11, which is what they wanted and what they got. All right. So thanks to this, the auditor came back, audit passed, compliant to 21 CFR Part 11. That was on one site, then they deployed this on the other sites. Traceability, digitalization, validation, recipe management, all done. Recording forever available on a database. Operation safe in the sense that if anything happens and is out of range, we've got an alert right away, not after an hour of waiting for the next temperature reading. And yeah, the audit trail is now constant, right? You've got a tick box every time that the batch is provided. So it's like well, this if there was an audit, would pass it, so no problem. It's all available and recorded. And we can trust it. There's no human involved. So, and yeah, data as well. Side benefit: data is available for maintenance. So this is where I'm gonna go next. Ready? The client here was very nice to give us the data, the right to talk about the use case, the architecture, even their batch records, more or less good and much better after that. But I'm not allowed to talk about the rest of the architecture. So the only thing I can as well speak with a lot of confidence is what we are doing at Schneider. So we're going to change a bit the scale of the type of sites. So we're probably talking about sites of 400 people as well, or on one single site. But I'm talking about an application landscape which is compatible with a deployment across 300 sites globally. And this is what it looks like. So this is a functional architecture. We're not speaking about systems, solutions, or whatever. It's that the first question we need to ask ourselves is, what do we want to do with our data? So I'm just coming from a place where they just wanted to monitor the batch records. Monitor the process to get the batch records electronically. Is the first step to get the data in order. You remember this SQL database which was sitting somewhere, right? So this is where the core of the operations is living, right? This is where the truth is. Now we're building on this. So hopefully you're gonna hear me. Edge control, do you remember in the architecture it was in the middle, right? You've got controllers there, you've got a bit of software, there's nothing, it's a bit system specific, a bit technical. The electronic batch record is here, and the process control, right? Interlocking, traceability, this is where your operational data sits, and it feeds all the rest. At Schneider, we have a manufacturing operation management that feeds off here, who's doing the production wheel and managing work orders. So we have either engineering to order, or made to order, or made to stock. It's all managed here, and here you would have the where the production orders are managed and sent to a production line. It's directly connected to the people management, because from here you're going to have work orders with association of people responsible for actually doing the work. And it's closely interlinked because the objectives here are actually supposed to be followed by the people. And this is when you remember the example I've given about this spirit industry, about this person who managed to improve the line throughput by 11%. Or here, the single short interval management tool is here. Right? And this is where we escalate issues. Like on the shop floor, I've seen this. It always happened like this. Could we do something better about it? And then it escalates to the shift leader, who says, well, there's a bit of an investment here, I need to ask the plant manager. And then it moves to the plant manager. And people on the shop floor can see this process. This is the whole. It's extremely important because this is what enables buy-in from the shop floor to on the technology. Saying, okay, right, it's again a new technology to learn, but at least I can see the benefits. Right? And it's extremely important to get the buy-in and get people to use all those systems. All right. All of those guys are actually affecting the asset management, because asset management is based on the spec from the supplier of the machine, but as well the runtime. If you know how long the machine has been working for, then you know the wear and tear, or supposed to know, and you know when the maintenance procedure is going to be needed. And it's linked to people management for as long as the people are maintenance engineers, right? Then moving here, statistical process control. If humans are involved in quality checking, then you've got either delay or human error possibility. So we are working hard on finding solutions to automate checking, right? So cameras, detection, machine learning on detection systems, any kind of parameter that could tell that the end product has an issue, or anywhere in the process if the parameters are out of range. And then correlation with external factors to figure out if there is a quality issues which are coming on the back of special weather conditions or temperature in the room, or lack of skill of the operator that can affect the yield, productivity, output, or whatever. So this is all thought through here. And here, mostly, right? The correlation is probably more here on the analytics. Okay. And then you've got quality process management, which would be actually the method behind this. This is sensors. This is analytics. So this is the method. Okay. And the people who are skilled at this. Then logistics and warehousing, or what it is, what the tins, what's written on the tin says. Engineering to order, front-end project management is probably a bit too specific. Then you've got facilities management, right? If you want to talk about sustainability, you should probably start measuring somewhere the energy that you consume. Building management is part of the whole story, right? AI-based visual inspection, that kind of cross-check with this. And then virtual reality, that's for training, for design. I could have added for audit and for FAT, because we, for factory acceptance tests, because we do remote acceptance testing as well as part of our portfolio of services for our clients when we sell products. This is a functional architecture, right? Oh, sorry, I forgot the top. So ERP federation, it's ERP on all connected systems. Visualization, huge. At Schneider, it's absolutely huge. all this data is well organized, so it's made available to anybody in the company. We've got Schneider Electric Intel, which is an entity within Schneider who is digging into data. And for example, we got an award by Gartner last year because our ERP parameters are actually AI driven, and we've got machine learning loops which are looking at the size of batches of lots to transfer from factories to our warehouses and then to our clients. We've got well, lot size, we've got frequency of travel, we've got sometimes the type of suppliers who need to take care of it. So we've got plenty of parameters which are optimized because this data is actually made available. In the first place, because there was a process control system which was put in place and was putting the data in a right shape, in the right place. And then the industrial data lake, well, don't do this at home. So the data lake is well structured, right? There's a lot of thinking behind it. Data is another story, right? And if we look what's under the bonnet of those of this functional architecture, we start looking at an application architecture. But because we had the functional architecture in the first place, where the functional architecture was telling us what we wanted to do in the first place. And now behind this, you've got systems. You've got the various elements. So Aliva Edge, we saw it for earlier in the architecture for the client. I don't know if you know Node-RED, but it's bare bones piece of software that allows you to capture information from sensors and IoT, basically IoT sensors, and routing them to a variety of software, cloud-based. So Machine SCADA Expert is one of them. Node-RED is capturing data from temperature on the various part of our process and feeding it to Machine Data Expert, so that we've got alarms when things go out of range. Right, you've got servers and edge boxes and all the rest, but this is kind of IT, OT, IT stories. But it enables this to work, the lean digitalization system. And make a case for standardization, but at Schneider, if you want to be a smart factory, the plant manager of a smart factory, you need to implement this in your factory, no choice. And it's a system that you have different modules, you can adapt a little bit, but the core is not negotiable. And everybody at Schneider has it. That means that up there in the industrial data lake, you've got some kind of standardized data. Right, that was my case for standardization in a big company. Right, and then you have the lean digitization system, which enables the short interval management meeting. Right, I could go further there. At Schneider, we have 90 applications which are officially part of the catalog for our smart factories and distribution centers. We push all the factories to get to use those ones. In truth, there are 800 applications in our full application landscape, so we are struggling to, as anyone, to converge to those 90 which have been selected by IT and OT. But there is method in the madness, let's say, and this is as far as we got to. All right, that's me. I don't have much time for questions, actually. A bit?
We have time for questions, yes.
Very interesting, thank you, François, thank you. I want to bring you back when you said, and you were talking about McLaren or F1, about using the thinnest slice of data to do analysis. Every data integrity neuron in my body started to twitch then. Yeah. Because that's, you know, a classic where you are fishing for data that makes it look right. So could you explain what you meant by that doesn't give me nightmares tonight? in preparing for my next data integrity audit. Thank you.
So let's look at an example. I've got a distillery manager who tells me, right, I measure the performance of my plant by measuring the yield from grain to spirit, right? For so many tons of grain, I get so many liters of spirit. And this is, if I get to 100%, I'm happy. So, and I'm like, okay, so if you do it in 2 months, it's the same as if you do it in 2 days. Okay, right. So, François, what do you want? So I'm saying, well, you need to calculate OE, all right? So, but I have a continuous process. You have batches. Okay, so how do I measure my OE? First, okay, OE. We landed the discussion on OE. How do we calculate OE? Right, availability, quality, and so on. So my quality is always 100%. Okay, so that was the answer from the plant manager. So right, so what are the parameters that determine the quality? So we can start from where the process is at the moment. So there's a nosing exercise which says we give a grade from 1 to 4. Well, that was the quality part. Done. Availability. How long does it take to produce a batch? 1 week? Well, no. Okay. So you have downtime all the time. You have micro downtimes, big downtimes. You have outages. So right. So how do we measure this in pieces? What is the useful time? What is the available time? So you break it down. It's not magic, and then you get down to the few variables that are making the OE calculation. When we are there, we look at optimizing. But first, we need to figure out how we actually make the calculations in the first place. And then you get to do the audit. The auditor comes and says, it's not exactly like this, and I would like to see it. And you iterate. Continuous improvement anyway.
Thank you very much.
Will you sleep tonight?
Very quick, very quick.
Thank you very much, François. You know the people one where you said you set the targets, the 11% increase, and the 2 purple blocks. How many times did they beat their personal best?
So I can't tell. This is a very new project that has been implemented like a month ago, right? It's a bit early to make predictions, but it's they beat their best, yeah. And we implemented this in this same distillery, and they made the best production week in 100 years 2 weeks ago, right? Just because the guys are turned on and getting it.
I think it seems we have to sample more of these spirits tonight to help them.
I wish I could tell you, but this one is under NDA.
Okay. So thank you very much.
Pleasure. Thank you very much, everyone, for listening. We'll be during the break. We'll be next to C10 booth, next to the coffee area.